and I start dflow. Thanks. I start dflow. You guys start dflow as well if you have it. So we'll show you some stuff, and then you'll have time to practice, and then we can discuss it together. When you start your dflow, you'll see such a thing, right? Everyone is here. In terms of like I mean, did you start your dflow? Okay, Victor. So yeah, anyone? Yeah, feel free to ask question. If you have any questions, let me know. But if you open it here,
Sim. Sim. Questo business.
okay, if you are here, this is our dflow. As I said, it's like any other software, you know, like file, etc. It has an area that you can do the coding or can do the visual programming, we call it, and an area that basically you can do all sort of what you call it. I think I'm muted, right? Can you guys hear me well or no? Yeah, okay. So because yeah, I heard something from you guys. Anyway, so for instance, look, we have like mocap, we have like platform, you know, then bring them so the platform is there, right? And imagine this platform, which means something like this. This platform here that I showed you here, easier to see it here, this platform, right? Simulating that platform. And imagine I want to just move it, right? And see how quick we can do that. So we have platform and we have the generator. You see, I'm just bring like drag and drop and connect it like that. And then basically connect this. We have different types of motion. So you know, I told you a 6-degree of freedom, left and right and up and down, right? So when you do that, you connected it, and here's connection. What you need to do, like F2, you do F2, and then the runtime console will come, or you can actually go here and then runtime console. It's the same thing. So when you do that, you simply engage the system if this is similar. So if you have 3 of them, doesn't matter. So it's okay. Like engage at the very end, and when you engage it, so look what happens when I just run. Can you see that? It just actually moves, right? As simple as that. And interestingly, what I showed you here is exactly what happens in the lab. So even whatever you do here, it will actually happen in the lab. So imagine you have this idea, you want someone be here and being moving to left and right, but you want it to be a bit more. What it means, if you double click on the generator, you see the equations are there, like sinus of time. Time means, you guys, if you have any question, can you just type it for now? And then, if you want to talk, then basically unmute. And I can unmute people here, but it would be good that we are. Um, anyone has any question? No? Perfect. Because sometimes I hear like my own voice. Sorry. So you can see here like sinus of time. Sine is like, going between negative 1 to 1, right? And that's why you can see here, this is the movement. It's just going to the right and coming back. But if you want to increase it, you can actually do what? You can actually say multiply by 2, let's say, right? And that will change like twice the displacement. So imagine you want to even not just see it here, you want to also see it as a visually you want to see. So you just come down here, find graph, bring the graph here, and connect the graph like that, and double click on the graph, and you see the movement. Does it make sense? Can you do that, guys? Let's just try to do this, whatever I showed you. So I'll show you again. So I brought the platform from here. Platform is here. Hopefully you have it. If you don't have platform, vgate also would do it, because platform sometimes is for Karen, but if you don't have it, vgate also, you can bring the vgate, and the same idea, doesn't matter. And then but from the platform, create generator. So I brought a generator here, okay, and delete it as well. And then connect generator to platform and connect it like that. One of the channels to position of X. Position of X means going to the left and right, okay? And then go to add view and runtime console, or just F2, the keyword, the key F2, and here like V go runtime console or F2. Then you come up here, flow runtime console, and engage the system, and then play. When you play, you see something like this. And if you want to see, for instance, the graph as well, the graph that happens, like I said, here you come down, you bring the graph and connect it. Yeah. Is everyone doing it? Like, is it possible to do it, or show me like yes or no, or so that we can move to the next. Yes, perfect. I can hear. Awesome. So people are doing it fast. Awesome. So this is great. So you did your first app, your first application, basically, as simple as this, and you can build up on that. So what is happening now? Let's imagine what we wanna do is, so we are here, okay. So you learned the basic of the flow, and then you are here, move the platform. But what I would like you to do, or maybe I can show it to you guys, and then you try to do it. So sometimes you just you are, because it is a virtual reality. What you want to do, you want to move objects. Say you have a person there and want to move, okay? And you have like an object, like a ball. So you see someone is walking on the treadmill and a ball going up and down, for instance, okay? So you want that ball to move. How can you do that? So this is what the question that we have, and now let me show you. If it's okay, guys, because the question is, someone asked if they don't have the software, just watch, if you don't have the software, but that's fine. Just watch it. You'll learn also, hopefully. So I'll go to the software again. I can even start over, new. Everything's from the beginning, and then I'll bring the VR here as well. So we have the virtual environment and the actual devices, okay? So what I wanted to do was what? I wanted to create a ball or a cube. So I'll go to scene and then add scene, okay? Just give me a sec, guys. Make sure you see everything I do. And then, okay, you see. So you go to add object, and then the object will come up like this window. And then let's add, say, a cube. Okay. So you see that the cube is added, right? Going to my here. So here's the cube. You see that? And what I do, I just bring this cube here. That's now an object. Now I want to move it. So I bring a generator and then just add the generator here and connect it to the same thing. So you can connect it to any of these things, but you connect it to, let's say, in X direction, okay? You can even connect it, the second one, to Y direction. So what happens then, F2, and you play. You see that? It actually started moving, right? So I'll do it again slowly, and You guys follow. So I just start from the beginning. What happens? I even go there, new application. So I'll go scene, add object. Then you can change them, the names, but it doesn't matter at this point. Cube. Okay. So you created a cube. Then bring that cube in. So this is an object. Now bring a generator. Generator means generating, you can see here, signal, like you it from one point to another. Then connect the signal generator to the object. Then connect the channels, the first two channels, right? And then F2, runtime cancel, and then run it. Good. So you see that very simple, we created that. And imagine this is basically your visual environment, and then you quickly want to have someone on the platform, okay? And in fact, I can actually move this so that you guys can see what is happening. So you see that's moving. I moved it, and a person would be here, and then I just want that person to sort of up and down as well. Okay, and this is your next like the second application. So I just don't want to do I don't want to do the platform, but just try to do this for now. Just wanted to give you the why we do this, right? Like close the platform. Can you do this in maybe a few minutes? Someone has a question? Yes, Romain, please go ahead. Unmute yourself and ask your question, please.
Yeah, sorry. Thank you. The object doesn't move when I use the runtime console and press play.
Did
The
you
object.
connect it like that? Did you connect it like from here? So when you click on this line, there should be a line here, connection from
Yes.
generator to object. Do you have it? And then the channels should be going to these two
Oh no,
switches.
at the bottom the channels are not connected the same as you. Okay.
Yeah, connect them as it is, because that just
Oh, that's
defines
it.
it.
Yeah.
Yeah, it works
Thank
now.
you.
Yeah, don't worry. Perfect. Yeah, it should work. So excellent. So this is moving, right? Everyone hopefully is doing. Someone is asking question. I can't see who, but go ahead if you have any question. Mute yourself, and I think it was still Romain. Yeah, that's fine. So hopefully you guys did this. The next step is, let me see where we are. Yep. The next step is, so you basically did this amazingly. You can actually now change your system, like bring your virtual environment, and to this connection, you can, as we talked before, you can change that, right? Like say times 4, and you can see that's basically changing 4 times, like bigger. And interestingly, you can actually have equations or things here as well. If you double click here, you can actually add things here as well. It's basically the same idea. I don't know if you got what I did. So in these lines, you can add equations. So you double click on them, and then, and you have options. You have so many options here, like addition, subtraction, etc., or condition. You can actually have all sort of, in those of you who know the programming, you can do all sort of things like sine, cosine, etc., variables. This is quite a lot of things you can do with it. But I just leave it to you guys to explore for now. Okay. Cool. So this is your second one. Amazing. You guys are doing well. And the next step that we wanna do is a sort of a challenge. So I give you guys like maybe 4 or 5 minutes for this challenge. So you guys learned how to do the what you may call it, moving an object in the VR, in virtual environment, right? This object could be anything, could be a person, a character, anything. So now imagine we have an idea. You guys have an idea. You want to have a person walk on the treadmill, and then you have your object to go spiral. So that testing their like visual flow. You know what I mean? So there are lots of games that people actually doing similar ideas. So I want you to try in the next couple of minutes or so, maybe for 5 minutes. It's 4:07 here, maybe until maybe 10, 15. Can you try this? This is a challenge. See who can who can create this basically. So here, what we did, it was simple, a back and forth or a kind of circular one. But what I would like to see is the circular one that just goes all the way up or all down. Is the question clear? And can you try that for a couple of minutes? Then we will do it together, okay? To give you guys a tip, you see, if you have these channels, so each channel talks about 1 degree of freedom, like goes to one direction, the other direction. So we have 3 directions, like in 3D. So what I showed you in a spiral is 3D. So basically, you need things to do with X, Y, and Z, right? So X and Y is like this, and then the Z would be like that, right? So if you do that, it's quite simple to follow, right? Okay, anyone, any success? No? Any idea? Kind of showing it to you guys, but let's see what the. Oh, well done. If anyone has done it, can you share it to us? I'm happy if you share your screen and talk about it. Just try to share. I give you access to. So they did it. Oh, okay. Someone says, I think. Try. Yeah, Stephanie says I can try. I'm remoting into. Okay. Well, that's fine. I thought you guys did it quickly. So if you can just share it to us. If that's difficult, that's fine. I can go ahead. ahead and show at least, because there are lots of ways to do this, but there are simple ways. I'm gonna show you now. So I told you that it's like three degrees of freedom, right? Because you have like X and Y and Z. Just basically it just moves like in all directions. So one equation that you can try is these ones. All right. So let's try all together. Just follow me as I do it. So this is like a time times, sine of time, and then divided by 10. And then you need to enter, type in, like press enter so that the equation would be there. And then time divided by like 10, and then time times sine of time, then divided by 10. Okay. So now let's see what's happening now so I got these equations from these two websites. You can come up with any equation that you like. So can you see that? It's big. Here we go. Just bring this B. So you see that's basically what is happening. So this one goes all the way, just like all the way up. Maybe the best one would be I'll bring other object. You can see that this one, like that the beautiful thing about dflow is I can do it online. So I'm actually it's on and it's playing, and I still can do things. So let's bring say a sphere and make it say blue, and see that's there. And then I just I can even cut and paste or copy paste. I can copy this generator and paste it here. Did you see that? So I went there and just Control C and then Control V and copy and then paste. So again, everything is the same. So all those equations I don't need to write. Okay, and then I bring this one here, the object, the second object, which is this, and then add to it. And connect. The connections would be similar to connections, right? Just these two connections. These, sorry, three connections. So I just connected one, connected two, and connect three. Yeah, I'll show you the generator. Here's the generator. Let's just type it. Okay. And I start over. No worries. Can you see that? Even this one, because it has got a trail, and it actually shows you, the other one doesn't have it, but it's doing the same thing. But this one is showing exactly what I showed you before. Do you know what I mean? Does it make sense, guys? Yep. That's the beautiful of like a coding real time, yeah, no worries. And it just goes on. And you can now change it. You can change all these things, live. And the cool thing is we are not even in the lab. We are doing it everything here, on your own computer. And you want to decide, say, okay, is this good enough for my subjects, So we have projects like, we have some of you guys here who are doing projects with us. You see that we are discussing it on the computer a lot. Because that is the way, in my opinion, that the whole design should happen. Before you go to the lab, I always tell my students, don't go to the lab without a plan. The plan should be here, right? Well, anyway, did you get it, guys, everyone? Happy to move to the next level, or you want to still practice, or you want to add these equations to your generator? Yeah, if I have a few yes to move, I'll move to the next topic. Or if you want to keep digging a little bit and trying to simulate this, just take your time, a few minutes. It's really worth it to have a look what's happening, and it's very fulfilling as well when you create something like that. And you see that if I change it right away, everything changes This is actually the other generator. So if you go to this generator, if I do, let's say, make this 5, you see, everything changes. And the other one also. Live real time, right? And imagine this is like your marker. So I'm just giving you some ideas. Imagine these are like markers from your motion capture lab, okay? And then you want to do some sort of like a, what should we call it? Filtering. So you just bring it here and then you put it here and then filter it. That's it. Done. And then you wanna graph it. You graph it. So you see it. You see here. You see it here. And you have all sort of options too. That's basically the way we design things. I hope it's not too fast. I don't expect you guys to do all these things, but I'm just giving you ideas, like what are the possibilities, okay? So the whole idea of this D-Flow workshop is this to give you an idea of what are the possibilities, and then if you are very interested, we can dig into each part of it, all right? I like the other one. I changed the generator. It's just going all over the place, going all the way to the D. I see this one is because I changed it, I think, to 1, get like 5. So it's just not going too fast. Anyway, isn't it cool? Okie dokie. So the reason actually that trail is staying and not all of them staying is because I changed the duration. So you can change this duration to whatever you like, and then it will keep the trail. Okay. Okay, that's your number 3 or 4 applications. And it's very simple. If you like, I have actually one video that shows there's a paper published in Journal Biomechanics recently, and I actually tried to reproduce it. And the methodology, we reproduce it in 5 minutes. Of course, to go there, it takes 6 months, 1 year, right? But we have software, we have hardware that we can actually go there quickly in terms of application building. But then doing it, analyzing, etc. These are another story. But the whole idea that we have is like this part should be easy for users, for anyone who want to use our systems. We want them to be as agile as possible and as quick as possible, and they really enjoy even watching what they're doing and observing the results way before they go even to the lab, right? And that's a beautiful part of it. All right, I think we can move on if you guys agree. Yeah, let's just move to the next part, and let me see what next part I've brought for you. Okay, you created your app here, this challenge, well done. And yeah, this is actually another big area. Some of you guys that if you have done programming, or even if you haven't, you notice that you do something, right? But then it's not that part of it is important. It's important, of course, writing codes, etc. But most of the time, the first time you do it, doesn't work, right? Most of the time, it's the case. And what is happening in computer programming, it's called debugging. So basically, you do something and then try to understand why this happened or why this didn't happen, right? So we have a lot of options to do. We have a lot. So we are actually moving toward new software platform that will be much easier. But even here, still cool things happen. So you remember one of the applications you guys built was a generator. First one. We had the sinus and cosine of time, and there was a platform. And then you plot it like that graph. So what I want you to do, quickly build this again, right? I'll do it again and you watch it again. But once something is interesting here, that so you can see here from generator, there is a signal going to platform, and that the same signal goes to graph. So in theory, they should be similar. They should match one on top of the other, right? Is that correct? But you see that when I just plot them, they're totally different. All right. So that is called, like, what we want to do is debugging to understand why this is happening. So I'll show you now here. Everything from scratch again, 0. And then what I'm going to bring you, remember I said generator, and I said platform, right? And I said what's the other one, which is here, the graph, right? That's it. These are the things you need. So you can actually code along with me. Generator, I said go to graph, from generator go to platform as well. The graph itself actually connects it, but for the other one, generator, you can actually connect just the first one because we just want to look at the first one. And then when you're done, click on the graph. You can actually make it bigger as well. And because we have two signals, this one, actually we need to connect this one here, right? Because we want to compare the output of platform and output of the what we call it, generator. So we are from here to here. I'll do this slowly again. From generator, you want to move the platform, and there's an outcome for it, like the platform moves, and that comes with sine of cost, sine of time, and that outcome will be given to the graph. So I want to give it to from here, delete everything. So from the platform x, give it to the first graph. Makes sense? Then go to the generator from the channel one, because channel one is from graph one is done. So we gave it to platform. We go to the graph two. I'll do it again and you watch it. So I just select these things. So we have just two. So I'll do it again. Generator, from generator, go to graph. From generator, go to platform, and platform to graph. And click on the this line of the signal of the generator to graph. Connect it from channel one to graph two. For platform, click here, the signal from platform to graph, go position X to graph one. So now we have two graphs coming the signals that should match, right, in theory. But look what happens. If I do F2 and then engage the system, because system is not engaged, so it's not going to the VR that you see what I mean. Okay. So you see if it's off, see nothing happens to here. But what I do is I engage the system, okay? I wait everything would be 0, okay? Now I want to compare these two signals. To compare them, do you see they are totally different, right? So I want you a couple of minutes to explore this, and I assure you that there's nothing wrong with the software, okay? So you guys try to see if you get, this is called debugging, if you get why this is happening. Yeah, it's a quite simple application, but we get totally different results. That could happen to any application. You expect something, but you see something else, right? Can you do it? And can you try to understand what is happening here? Any idea that's what is happening here? Why one signal or generator that creates sine is different? One of them is sine properly because that's coming, this is sine, but the sine coming from platform, it's moving like sinus, but it's showing us totally different graph. Okay. If anyone has no idea, I can share a little bit of why this is happening. Yeah. You still want to work on it, or you want to hear what's happening? I assume that you want to hear what's happening. Okay, what is happening here is, we have our systems. They need to have a check and balance. So you cannot just give them any kind of like movement. So have a look at what we had here. In our platform here, for instance, the platform should not move like huge distance, right? So when you say sign of time, it means can go between 1 and -1, means 1 meter it can go, but 1 meter is huge, right? Just imagine you're moving 1 meter. So that's why our system has got these kind of checks. So what is happening if you double click on the platform, you see that all these degrees of freedom have got their limitations. Okay? The limitation for sway is like 0.14, which means like 14 centimeter. You can go 14 centimeter each side, but we are giving it 1 meter. So you can see here what is happening. It's actually going to 14. It's nearly 14. It's exactly 14 here centimeter, and then it continues the sine side. Does it make sense? Right? That's perfect. So maybe I can maybe we can have a couple of minutes of a little bit of chat with you guys, because there's a lot of things we can discuss. But at this point, I want you guys can make it maybe call it like a little bit of rest as well, not just bombarding you guys with lots of information. That's not the idea. So what I do, I stop sharing, and if you guys don't mind, turn on your cameras so we see each other. And then, if you have any questions, or even if you want to go get some coffee or tea or anything, yeah, let's do it a couple of minutes or so, and then we will continue. Okay, I'll stop sharing and would be glad to see you guys, as well.
Hi, I have
Hi.
one question.
Sure, Laurie, go ahead.
Did I see correctly that there was a, a very slight kind of overshoot in the red curve in the previous example? So when there's a limit that 14 centimeters, it ever so slightly overshoots that, or maybe it reaches the limit, but then undershoots the limit ever so slightly. So is that something to do with the controller of the kind of the software side? Because this is now all virtual, no hardware actually involved in this. So
it's actually not for the actual when you do it in the lab, you might see it slightly, but it's still, because we have checks and balance, all the control systems are there. We can actually manage that. But here is just software, as you say, and I don't see much of. I can actually bring it up. And
I'm not sure if it was kind of a, but
very small overshoot. I can see that.
Yeah, very small. But I mean, because it's all virtual, I was just wondering why that happens. But is it just because of there is the kind of the control loop there, so there's some delay always?
It's a good question. At this point, I don't have the underlying equations or control, to tell you exactly what is happening. Is it directly we are providing just a number, just say, okay, go there from A to B, and that the software should go, and then that's the hardware part and control to actually adjust it or overshoot on. But I can get back to you guys. I have to look into that to see if even we do this through the software. Because it could even happen. It could even happen that because probably the earliest version, they have seen that we need to really make sure from the software side we do some sort of controlling, or even like maybe filtering or anything. It depends. I don't know what is happening underlying. But I can get back to you. Just email me.
It's not a critical issue,
of course,
at all. But it was just interesting to see, because I was expecting this kind of a behavior if there would be hardware included or involved, if we would measure the actual behavior of the hardware. But now we are just simulating, so
exactly.
Just
Well,
wondering. Yeah.
it is going in, but the cool thing, let's put it this way. The cool thing about this is actually we call it MDS, the medical device services. So that is basically talking to the from the APIs of every hardware, and then that comes to talk to our editor here. So I'm expecting, there's also papers out there, we've actually published them as well. I'm expecting to do something here. Maybe it's not just the hardware side. So I'll get back to you if you like. But it's a really good point that you noticed. I've done so many times this, I didn't notice this one. It's perfect. Any other question, guys? Someone raised their hand. I think it's Stephanie. Yeah. Go ahead, please.
Yes, I do have a question. It is 1:30 in the morning here in America. But my question is, of course, I have to learn. So my question is if you were to actually go back to that application that we were doing and you adjust the safety filters on the actual platform itself, it seems like the offset or the horizontal shift actually goes away almost with the generator and the actual platform. So would you be able to explain to me like what this safety filter actually does? Because in my previous code that I used for my master's, we didn't actually have this engaged and that caused some problems. But when we had the safety filter engaged, it worked perfectly fine. So I was just wondering, what exactly does this safety filter do?
So are you referring to the filter I showed you here or the filter within the platform, you mean?
The one within the platform.
Okay. Yeah. So you mean
because if you make it, go ahead.
This basically this one, safety settings, you mean? Actually, you can see my, sorry. I just maybe share
yes,
my
but it'd be the
screen.
safety settings and it'd be the safety
Here,
filters. So if you set it,
Yep.
Yep. So like if you set it at 0.1 or whatever, yeah.
Yeah, this probably, again, I have to look into the code, but probably it is the low pass filter. If so, what was your problem when you used this one? What happened?
So basically, I just inputted a sine wave into the platform. So I just had the platform going left and right, back and forth, and I didn't have this engaged. So when I would start the program, it would actually do a violent like jerk off to the side. And that could have been because I used the sine and the equation had to catch up with the math and whatever. Yeah. So it's just pretty much a dampener then? Yeah. Okay.
It's basically exactly like my understanding is it's a low pass filter. So I can have a quick look at think here, see if we have written it here. The one, the natural safety setting, yeah. Here, as I said, it's a safety setting. Let's see, second order butterforth.
Yes. Okay.
It's a low pass filter. So it's exactly what you mentioned. Yeah, this is for safety reason, you know. That's actually maybe it's Lauren's ideas of the problem that's maybe showing what's happening, you know. Yeah, basically read these two lines and that answers your question, right?
Yeah, thank you. Appreciate it. Yes,
perfect. So any other questions or anything that? So I would love to actually like have if you guys don't mind, before we go to the next a few other ideas that I would love to share with you guys. Maybe we can have a if you all are here, and if you can, and if you like, I do the print to screen as well, so I get a photo of all of us if you are around. I see many of you guys turn off your camera. That's fine if you don't want to be in here, but if you would like to be, I'm more than happy to take a like. Is that fine with you guys, or there's no one? I can see Laura. Oh, excellent. Don't worry if you don't want to be, you know, in this. Oh, excellent. Hello, Simon. Hello, guys. Excellent. So I just wait. Any other question that until no questions? This is a great question, by the way. Well done. Thanks for everyone going from all over the world. Oh, Chris from Brisbane, right? Hey, mate.
Yep. Yeah, can you hear me now?
Yeah. Awesome. Good to see you, mate.
Yeah, great to be here.
Yeah.
Thank you.
Thanks. Yeah, we'll catch up later, really soon.
Look forward to it.
Sure, mate. Sure. So we have awesome. Now all the weather, type of different types. So we are here in Melbourne, Australia, and it is. I see people in the car. Well done. This is amazing. Yeah, it's quite chilly here. I'm sure in Brisbane it's not, or in Europe or the other part of the world. You guys are in a quite warm environment. Anyway, so maybe I'll just take a selfie or this print screen, and then we will continue. Let's just look at your. I look at my camera as well. 1, 2, 3. Excellent. So if you don't have any question, I keep going. Here we go. You guys can see still my camera, my monitor, right? Let's move on. Yeah, you learned a lot about like how to move things. You can see this is actually the beautiful thing about I believe the VR and connections with the biomechanics and like multi-sensory systems. So you can do all sort of things, right? You can come up with lots of ideas, and some of you guys talked about it and you already have done it. Like this one, for instance, and you can study all aspects of it. So here is, okay, are we here or we talked about this? Oh, yeah, debugging here. Now, let's a little bit talk about perturbation, okay? Anyone doing perturbation? Yeah, awesome. So I have some videos online as well. Just have a look at them. Perturbation is something that I personally love as well. I've done quite a lot. I've put like maybe more than 100 people in the Karen lab and did all sort of, perturbations, and it is not only fun to watch people do all sort of being perturbed and reacting, but scientifically it's amazing how we do it and how our body basically reacts, or responds. Um, so what we want to do is quite simple. We just want to up and down, like you learned this one. So have your platform and then create like sine, go up and down, right? It's still very simple. You guys can do it now. And then what I would like you to do is create different speed. All right. So I didn't show you the treadmill, but I'll show you in a minute, in a second. And then these two parts should be simple. And then the third one, what I would like you guys to do is kind of challenge as well. What are the ways, or what's the best way, maybe, or how maybe you can come with different ways to do it, to show the feedback to your subject. That, for instance, the changes in their, say, their gauge to speed, or even the left and right side, So because we can get all sort of parameters, you can actually plot them or show them on VR. But just simply put the treadmill itself, left and right, and show the kind of the differences, right? As a biofeedback. So now quickly, let me show you what's happening. Start again. What we want to do is we want to start with, again, a platform, right? And again, a generator, and connect them, very simple. Then what we wanted to do was sort of rotation, right? So let's see where we are, one here. DRS, we call them, distributed rendering system. If you didn't know that, this DRS, distributed rendering system, because we actually render at the end on our screen. Okay. And then we want around X, that's correct. F2, engage the system, and then run. So that is moving, right? Still is quite small because it's sinus of 1, and because rotation is kind of, it's radians, it's not too much. So maybe you can say times 10. so that it will be obvious that changes. You know that you can actually remove all these things if you go there, click and press G, that will be gone. G. If you press A, that the axis will be gone. Okay? G and A. I like the network part, but the what we call it, the axis. Anyway, it's up to you guys. Does it make sense? Now you can do this easily. The second part, the third part, the challenge was the treadmill. So the treadmill and then the show it. The treadmill is simple as well. I didn't show you guys treadmill. Yeah. And then make it what? Say, so what you can do, you can actually hard code it as I go there and just do one side to 1 meter, the other side 1.5 meter. But usually what I like to do is, because I want to like control things myself, so I use valuator, they call it, right? So which means it's like a slider type of things. You can actually slide and change it, and even you can do it here, change it. I'll show you what it does. It's quite simple. You actually connect it validator here, and then give because we want to have two parameters. So the first parameter, give it to, say, this is a bit tricky here, because what we have different parameters like self-pace, position, self-pace, sensitivity. So we don't need them now. What we need is left and right speed belt. Okay, belt speed. So put, for instance, the first parameter to the left side and the second one to the right. Hopefully you can follow me. And then what you can do here, say you want to make one side 0.5, the other one have to enter, the other one say 0.7, right? Okay. And then you want to make sure, you want to see if they are actually showing what they are supposed to show. Connect. And then so you see actually what's happening. What we want is right side belt and left side belt speed. Just these two, 1 and 2. But why we do not get different values? Right? Didn't get to be, I put here different values, right? So which means that this valuator will provide 0.5 and 0.7 speed, and then give it to treadmill, and this is treadmill, and like left belt speed, right belt speed, and then this belt speed, we say left speed, right speed, graph 1 and graph 2. Why they are the same thing? Anyone, any idea? Idea? Don't be shy, feel free to. If you click on your treadmill, there's a trick. There's something here for the safety. We have put it here. So here, link belt speed. Okay. So the thing is, we link them by default, so that's, and because if you don't link them, people can do this, like different speeds, and then when you do different speed, have a look what happens. I just go there. You see what I can do. It's a crazy thing to do, if you really, if you have someone on the treadmill and then you just do this, one side is just moving faster or slower than the other. Make sense? So the challenge for you guys is, so I think so far you understand what I'm doing. So what you're going to do is, the first part was quite simple. The second part, you use validator, treadmill, and graph. And what you changed is the link one. So you need to actually stop it and then link or unlink, okay? And here deselect this one and then run it again. And now you can see two different speed, right? Right and left, two different speed. If I change them either here or here, say I make one, you want one, the other one is like 4, so you see they are changing. Okay. They can change either through a slider or here. That's kind of perturbation as well. But this is not what I would like you. This is what I would like you to do up to here. Then the next step is, as I mentioned, is this one. And you try in a couple of minutes or maybe a bit more, do this. Any other method to provide feedback for each leg? So I'm walking, but I want to get an idea that, okay, how I'm walking, like my left side is going 1 meter per second, the other side is going 0.5, bit difficult to walk like that, but it's like people are doing it, especially for perturbation and, perturbation training type of things. So what can we do? Can you think about it and try to use to have a look at all these things that we have here, modules. Yeah, I didn't tell you all about this, but I'm sure by now, by looking at them, you can figure out, okay? And even think a bit out of the box, how you can provide feedback, and what does it mean, feedback or biofeedback? So is it like, you want to show a graph, two graph, one on top of the other, like what I showed you here? That's one way. Like this, top of the other. Okay, that's one way. Or you want to show, let's say, I don't know, like two bars, right? Like something like in the VR, there's one bar and there's another bar, like a 3D model. And then one of them go up and down, depending on how that change, for instance. So I just wonder how you guys would provide feedback in this scenario. It doesn't matter if you cannot do it, just let us know that, oh, I would love to do this. I would love to do that. You know what I mean? So if you can do it, amazing. You just show it to us. But if not, just feel free to just type it or share it with us. Yeah, I just wanted to do it this way. I just wanted to do it that way. Okay. And while you're thinking, I'll show you another graph. This graph actually is just for us to understand why we are developing things. But there's another graph which will be shown on the like a biofeedback, as I said, and this VR environment is here. What's this? Here, graph 3D. Okay, you can bring this graph 3D and then change the location. If double click on it, just bring it back. Set that. Basically, actually go like that. Z. I mean, right? And then you can even scale it if you like. Imagine someone is there. This, okay. And what you want to do is imagine you want your platform to be shown here, the X and Y, or the rotation, for instance. This doesn't work, but you go there and double enter it. And maybe it doesn't show all of them, so you can actually go and change all these, divisions, etc. The range, because the ranges is not, it's just, let's make it 10, with 10, and you see that basically still, I think it's not 20, see here, right? This is one way of showing what you call it, feedback or biofeedback, right? Or I showed you a couple of them. This one, and this one, the other one, or maybe a bar chart type of things, right? Any other idea? So I'll give you guys a couple of minutes or so to think and explore, and then we'll be back. While you guys are doing it, I'll see how much we have. Yeah, he said until 5:30. Yeah, we can have any question and answer at the end. Let's see how much time we have. Okay, any ideas or anything, any ways to share with us that you would like to provide biofeedback to your subject? Or any study that you might be doing now. That's all also totally fine. And take advantage of I think we have here some experts as well. So take advantage of them, share your issues or anything. I think someone is.
So I would like to at least see how you would make the bar graph.
Okay, cool. Yeah, I'll do that for you. Anyone else here? Yeah.
Could
Yes.
you also attach like the size of the object and have say you had two spheres, one's larger based on one belt speed and one smaller based on the other belt speed?
Good idea. Very well done, Stephen. Yeah, that's a good idea. So you have like two sphere, exactly. It's like one scaling one and the other one like bigger than, yeah, perfect. Cool. Anything else, guys? These are really good ideas. And I quickly show you what I meant by like bar chart type of things. Let's see, I think I've shown it to you, to a couple of you guys before. So something similar to what Stephanie mentioned here. So you can have an object, right? So let's say you want to have stuff like sphere, you can have a cylinder, right? And then make it whatever color you want. Okay. All right, here it is. And then you bring it here. Actually, like now, they rotate it. Another one. Okay. Then move it. Yeah. Just wherever you want to provide, right? The feedback. Okay. And that is cool. And what you can do actually is add a treadmill, and then you provide a treadmill here. And then it was brought to what Stephanie said. You can actually scale it, and now you'll figure it out. Right? Build speed. Oh, because it's constant, so it's not going to change, right? But if you change it here, again, it's not going to change. Reason being is probably okay. Sometimes when you rotate it, I myself, I forgot which one is X and Y and Z. That's why I'm trying. You follow me, right? So you see that? So basically, it's just, this is one way. In X direction is just moving. So you can actually give it to other directions. Does it make sense? Just coming up and down, up and right. But you can give it to, I think, a scale it in Y direction as well. Let's see which one is now becomes Y. Left the speed. Yeah, you got what I mean, right, guys? Is when to make it 0, it just becomes 0. For some reason, it's not scaled that direction. It's not scaled. Okay, scaling in this direction. Okay, maybe this would be something that you guys can explore. You know. So it should work in the other direction, but for some reason it's not showing in this one. Sometimes actually you need to start it over. Yeah, I see here. Oh, actually, there's something that we need to. Okay, this is again the debugging thing. Because the scaling here, we actually constrain that. So that was the main reason. So if I it's basically all of them are connected when I do this, when I take you. So basically everything does that. Everything scales all together. When I do this, I can actually go one by one, right? Now actually it makes sense. Now I just go ahead and scale it. You see, this goes up and down, right? Does this answer, I think, who was asking, Lori? Is it you're asking, right?
Yeah.
It's actually a good point that this brought us here. That some of the things that we actually do it in advance for like constraining things, like what I showed you for treadmill. You need to, if you want to change those parameters, you need to really check. Okay, very good. So you learned quite a lot of things now. We learned that moving platform like the treadmills working, and then providing feedback, right? Even this type of feedback, or the type of, maybe you can quickly bring what Stefan mentioned as well, like adding object, bringing sphere, right? And that is sphere also, you know, if you to bring it here, right? Sphere first of all, then yeah, then constraint will go. Bring this one to X. Okay, so you see, or even for this case, because basically constraint makes sense, just leave it there, right? Good point, Josephine. Yeah, that's what your idea was, right? See how quickly we can actually do what we have in mind. Something comes to our mind and just quickly do it here in VR, or we have given all the options. And next step, I think we have quite a lot to cover, but that's okay. We can just come back to me if you like. Yeah, well done. We did this challenge all together. Oh yeah, this is actually something that I really love as well. It's a programming one. So you notice here we have quite a lot of modules, right? But as you know, you cannot have everything as module. So all these modules also are kind of codes. Like there's a script behind it that you can see, but basically we have done it, and then you just simply see at the end this like input and output, right? So if you see in computer programming, like we have functions or methods or classes, you know, we have like input and output. Some of them there's no output, but usually there's an input and output, right? So there's some arguments getting in and some argument going out, right? So that's the whole idea. But sometimes you can't really do that with all the options that we have provided. So what is the solution? The solution is actually what we provided here, scripting we call it. So there's this whole thing, software called like programming language called Lua, and it's embedded here. There's a lot of gaming happens with Lua, and has got a really interesting story as well. If you learn more about this, this is actually it's very similar to MATLAB if you used it, and I think they developed it in Brazil. And that time I think they didn't have much money, or they couldn't get MATLAB, so actually started their own, which is very similar to MATLAB, and it's free. You can actually use it for free. It's so cool. Anyway, so the idea here is very simple. So you have input and output, right? So unfortunately, I can't go through all the details because this is huge area. I know scripting, as you guys know. So I can just quickly show you one example, and then if you have any question or you wanted to learn more, happy to chat later. So we have input and output. You know, I mean, here is the place you can do all your scripting, okay? Or syntaxes here. And even you can bring objects. So you bring objects, then those objects you can play around. You know, like those objects we brought here, you can actually like bring them here. You know, connect them. Sorry, like that, you can just that. This is already there, so that's why you cannot. Okay, like that, and then you can actually see that, oh, that object here, and then you can actually manipulate that object here, right, in your code. So I'll give you a simple example to see what are the possibilities, and then can move on to the next idea. So you remember we did this graph, right, like here. Manually, I just brought that graph, drag it and drop it here, and I showed you how to connect it. So let's imagine we want to do this through programming, through Lua. Okay. So what we need to do is quite simple. If you just say, for instance, what should we call it, like graph, right? And dot create. Doesn't work, right? So let me just delete this, everything, and then maybe start from scratch so that I get confused with all other things. Okay, so we'll bring the script, and then I'll basically I'll say graph dot create. Did you see that? As simple as that. Did you notice what I did? I'll do it again. There's an error here, definitely, but I say graph. These are what we have created to do it faster, you know. Call it kind of API, you know. Graph.create, that's a function. And what I do actually, I run it. Start over, and I run it. It runs, right? So I just quickly have created something for you, and I don't want to type them all. It will take some time. And quickly I bring it here so that you can see what I'm doing. What is happening here? What's happening here? We just do initialization. Don't worry about that. So that we just do it once. We don't want to do it because what's happening in this software or this type of software, it just everything runs every frame. So that's why we need to really figure out the way to just do some of the things they call initialization, you know, or starting at that. At start, you just plot or do this. So what I do here is that as I said, like graph create, and then I said, okay, graph created, and then get the values. So here there's no value, but I'll attach it. So for instance, I have data generator connected, right? So from these channels, I input 1, input 2, all connected to these channels. So I get the channel 1 and give it to the value. And then that channel, or that G, which was the graph, I said set the value to that value, and then set the position, changing. So you'll see what's happened. Let's just run it. See that? In a matter of seconds, what I did, pretty much all the things that I wanted to do manually, I just created here, right? And then actually, I can actually manipulate it here. Now, these things I want to change. Let's say I call this one X plus, you know, plus Y or whatever, okay? And then, you know, if I run it again, and then that would be X plus value. Got it? So it shows the possibilities and what you can do with Lua. This is actually another amazing area. So, but some people it might be scary, but you know, it's just so lovely if you know what you're doing. Yeah, I'll show you again. See how quick. First graph, and the graph is there from the generator. Okay. Actually, because I didn't start it, that's why it didn't start right, like a sinus. Anyway, any questions or anything that you would like to? I have just one more thing to show you in terms of like some of the basics that I wanted to cover, and then I'll open it, you know, for question and answer. Just have like any talk until 5:30, which is nearly 20 minutes. Or do you want to practice this or any of these things? Feel free in a couple of minutes. If not, any questions? And if not, I can continue with the last item. I have some feedback. I can't see any of you guys, so I don't know how you think and what you think now. Should I move on to the next step or?
I think we're good to move on.
Yeah. Okay. Perfect. Okay. Next part Prepared for you guys. Yeah, we talked about Lua a little bit. Yeah, if you want to learn more about what I just said, here's the detailed tutorial, okay, that I prepared. You can actually go through all the details. Okay, the last part is HBM, okay, human body model. So you know that the end of the day, or not yet, just when you do biomechanics, you really want to know what's happening to the joints, what's happening to, let's say, muscles and ligaments, you know. And to know that, we cannot always get information experimentally. We can get like EMG type of things, you know, surface or even deep deep muscle, you know. But again, what is really what the muscles are feeling, what the forces are, you know, we can't easily measure them with muscles that we have. For instance, the upper body has got like hundreds, you know, like 800 muscle fascicles. So how can we really measure them? So the only way at the moment is through computer modeling or biomechanical or mathematical modeling, so both mathematics and physics. So we have HBM, so we call it, it's similar to you guys if you're using like OpenSim type of things or anybody. And I'm telling you, so if you are very interested in OpenSim, I do a lot of modeling in OpenSim, and follow me with that if you are interested. We have a couple of things that recently we shared with. It's a very simple thing that you can run OpenSim in any platform. Anyway, but that's different. That's my own personal things. But this is HBM from the Motec side, and it's a really cool full body model and real time. We can actually provide feedback. You know, to some extent, the full body we should actually confess that it's not exactly, you know, the most accurate one, but overall it's quite good in terms of the visually. What if you want to show it to your objects, you know. And how it works, there's quite a lot of things happening with the mocap module. Here's the mocap module. It's actually good, you guys, because we actually covered quite a lot of these. When you double click on the mocap, you see there's quite a lot of things happening. Okay. So we have, let me bring PRS here. Well, just watch what I'm doing, and then I'll explain what will happen. So what I'm going to do is just bring the HBM and make the HBM walk. Just follow me. I don't expect you guys all do it exactly like that. As I said, it's just more showing you what's happening, okay? Markers are there, and HBM is here. Sure. Yep, for something that's, so you can see the markers are here, and you can actually run that. It's not connected now, so the markers are starting to walk. Just remove this. You can see the markers are there. Turn it on. The static movement, and then the person starts walking. So what we want to do is match this with our HBM, like human body model, and then sort of calculate all the biomechanics behind it. Okay. So I enable this. I start it again. This is good. This is good. Analog is good. Here. Okay. Sometimes when we do that, don't worry about it. This is in the lab, it doesn't happen. But sometimes here, we just go to lower limb and have any start the gate analysis. Fine. So I started and then calibrated. So when I did the calibration, you see the calibration is done, and the person actually is, yeah. And now we have everything. We have all the muscle forces, and I can show you the outside here. So if you remove everything, just go with like HBM muscles, so you can see all the parameters. Yeah. Okay. And then you can easily plot them as well. So you remember they connected. want to go, okay, it's like biofeedback type of things, right? And choose what the muscles would be. Go ahead with that, right? I think we chose certain muscles that are not doing much, but can have also other things. Let's say and bring the force plate, and then say the force plate in Y direction to graph 1. Okay, and then as you can see here, the graph is not. So you can see what's happening. For some reason it doesn't show here, but I think the other one. I usually start with this graph and then the other graph. Close here, connect here. You can see all also possibilities here. Make sense? I don't think we have much time that you guys practice, and it's a bit quite a lot of steps here. We've done it like automated. It's quite easy to do all these things, in some of the programs that we have. But you can see all sort of possibilities in terms of showing the ground reaction force, and even now, even some of the biofeedbacks you'll learn, you can actually provide them like from these graphs to that, and all these options that you have here. You can select from mocap to the graph. Does that make sense? We have around like 10 minutes or so for any questions or any discussions. This was pretty much. I'm glad that I could cover most of the things I wanted to cover. Let me see if I have missed anything. What you guys are thinking? Oh yeah, this is basically what I wanted to show you guys. Yeah, here is the file. If you want to play around with what I showed you, just click on this or send it to you guys now, then you can later on do whatever you want to do with it. Here we go. And that I used in the mocap to show you guys. No questions? So this was also the things I wanted to cover today. I'm glad that we are really good. The timing is almost there. And while you're thinking about that, we can open now for the discussions, And I would really appreciate also we have like just 3 questions here as well, so that we can plan better, next time if we have we want to have next round of this type of workshops. If you just quickly do this, we can do it like just after as well or right now. But I'm more than happy to stay here in the next 10-15 minutes. If you have any questions or anything about what we discuss here or anything else, your own problem about our devices, about the T-flow, about the studies that you're doing, that some of you guys ask a couple of questions. Thank you. I'd be happy to chat. Feel free to turn on your cameras. I would appreciate that. Go ahead, Stephanie. Yep.
So I guess really not a specific question, but more, I guess, advice from you. What would you suggest to beginners and experts alike when learning and interacting with this software? Like, what should we keep in mind while we're working on this stuff and developing our programs? And I guess what's the best way to take on those larger ideas, I guess?
That's a very good question. I think it could be for everyone, Stephanie, and even when we want to develop things, we actually go back to this. I'll tell you now some of the ideas that we can help you. As I showed you here, You see that most of the things I showed you is very simple, right? But they can easily be expanded. So always we recommend that if you want to do anything big or small, just to start with something that basically works. Very small ideas, because even the biggest ideas can be broken, into different like modules or steps, and then you can implement them slowly. So I can show you, for instance, I can show you what I did here that took me nearly a year. This idea I see here, I don't know if you can see it here, right? This
Yep,
this
I can see it.
idea, yeah, this idea took me nearly 6 months to a year, and I basically what happened was every part that I couldn't do, like coding in Lua or finding like targeting, you see here basically someone. So it's like someone finding a target being perturbed, and the perturbation is random each side, and these are random, and the person is trying to find the target, and the gate speeds also we randomize them. So all these things, and I actually, what I did at the end, it was just all automated. So I didn't need to do anything. It was just click, a few click, and then go all the way like 1 hour or so for data collection, and even the collection with the icon system. But what I want to tell you is I started very small. I said that, okay, I want to do this part, and then I make sure that works, because our system is modular, not just this one. All the programming type of things are modular somehow. So when you do like one small part of it and test it, so you should be able to do and test. And another major thing that I always tell my students or colleagues or people who are working with our systems, I tell them that, look, you don't need to go to the lab quickly. You need to really understand what is happening with your what the idea you have, and you should show me or show yourself or your colleagues that it would work on the computer, like DFlow type of things, like an emulator to some extent. And then because we have like C2D file, did you notice here what I did is actually is another cool major things that we have. So actually loaded a file, right?
Mm-hmm.
So that means basically we are in the lab, right?
Right.
We're in the lab, so you don't need to go. We are in the lab, and you can do anything with this. So you want to do like jumping and landing, etc. You don't need to. You can bring the C2D file from jumping, but I mean you can try all your ideas with this simple thing, right?
Mm-hmm.
And then when you're comfortable with that, then you go to the lab, work with one or two people, and then come back. It's just very iterative, and that iterative mostly happens in the beginning here. And that's my what I actually always tell everyone, that start small and test as you go. Go to the lab when it's really needed. People actually go to the lab, I think, very early, and they go to the lab to do what? You know what I mean? Um, uh, you need to have a plan. So yeah, I hope I addressed.
Oh yeah, very much so. Thank you
Oh,
very much.
no worries. Yeah, glad to hear that. Any other point or question or anything? Yeah, please feel free. Don't be shy. It's actually some of these things you feel like, oh, it's easy, or the questions, it's all everyone's questions. It's just I had this question. Like I remember, I was actually thinking about another story. Like when I was doing my PhD, it took me like 2 years to understand that I was doing totally wrong. And it was in a meeting that someone came to me and told me that, Hossein, did you do this and that? Did you do this? Took me another year. And I wish actually someone would have told me earlier that, test every step that you go. Make sure every step that you go is evaluated, and is valid. And, we have two things in the biomechanics community is big. It's called validation and verification, Verification is all the steps are correct. Validation is, for instance, you get your forces, like from muscle forces, is it correlating with your AMG, for instance? There's a lot more than this, but I mean, keep these two in your mind: validation and verification. Every step do that, and then when it's at the end of your, and automate things. Then at the end of your like PhD or research or whatever you do, then if someone come to you like what I had here in my PhD, someone say, oh, did you do that? then all these modules, you have done them. You just quickly go and say, okay, yes, I've done this. So up to this stage is correct. And then I go to the next. Yep. Great question. And anything else? I would be glad to hear from you guys, your experiences, your, I don't know, what you want to do if you have the system, or if you don't, would you like to really continue developing things, with the software that you have? Would you? Basically addressing these questions that I ask you. Appreciate that. Yeah. Any questions? Stephanie, go ahead if you have any questions.
Sorry, all the questions tonight.
No, it's okay.
So when you make your visual environments, how do you create the meshes, or like what program do you use to make those meshes, and how do you incorporate those meshes into, I guess, DFlow, if that made any sense?
Yeah, definitely. It's also another great question. So I quickly show you here, but then I'll refer you to a video I created on how we actually generally you can do that. So same thing, like here you can bring some primitive objects, but then if you want to bring what you mentioned is scene here, right? So for instance, if you want to bring a scene that you already created somewhere else, so this is the scene, for instance. Did you get that?
Yeah, saw that. Yep.
So that's basically the way it is. So you bring the scene, but how you create it, you cannot create it here, but you can create it somewhere like a Blender, So I have a tutorial on Blender. Just go to our Mautic, I showed you here, Mautic videos tutorial, and I have a video there just talking about that,
Oh, perfect. I'll just go over there.
Exactly.
Thank you.
Right. You can do anything basically with that, and so it opens up sort of things for you.
Awesome. Thank you very much.
No worries, Stephanie. Any other? Yeah, thank you. No worries, Romain. You said that he's leaving. Yeah, we have a couple of minutes or a few minutes to wrap up, but feel free if you want to stay or you want to ask any questions. Feel free to ask me. I'm here until like 5:30ish. It is like 5 minutes or so until then. Yeah, I would also appreciate if you guys can do this for us, like this simple. That would really help me and the team to better understand what to do next. It's now your DFlow is your friend, so I would really dig into that and try to sort of so maybe I quickly tell you a little bit about. Yeah, I forgot this one. Always appreciate that. So these are some of the things you can connect with us. So it's my handle in Twitter, my email hossein.smokhtarzadeh@dih.com. This is the Mautic one. We have Mautic community. I think you guys can be called part of Mautic now, but this is more of a private one, and hopefully, let's see, maybe I can bring you in anyway. So you just try to connect here with us, knowledge, and you can connect with me on LinkedIn as well. Knowledge platform. There's a lot of things happening here. Video tutorial, like check out Mautic YouTube. We try from time to time bring some ideas, both from our customers as well as the our own internal development. Thank you guys for joining us. Yeah, feel free, guys. You can stay and ask me any questions until 5:30, because I said until 5:30, or if you want to leave, no worries at all. Thank everyone. Thank you. Special thanks to everyone. It's like 1, 2 a.m. Yeah, I didn't know that you guys coming from North America, but thank you very much. Yeah, I had this experience when I was in Boston and my wife was here in Melbourne. So yeah, really difficulty. Awesome. Any other questions, guys? Yeah, feel free if you have any. I hope this was useful. Yep, Stephanie, you have a question? Or?
Oh no, I was just gonna say thank you very much. This was awesome.
Oh, thank you.
Have a great rest of your day.
Yeah, you too.
Thank you.
Enjoy your night. Yeah, have a good night. Go back to
sleep. Thank you. I will try.
That's hard.
Hossein, thank you very much. It was it's Simon. Hi. It was a really nice covering a lot of different aspects because, of course, DFlow is quite complex. There are lots of things that you can do with it. And perhaps you mentioned and I missed, but are there online tutorials? I remember at one point there were some of the things you covered. There were at least PDF files that go through step by step of how to do this. Are there other things and maybe repositories with videos, examples, for example, the whole scenes, and maybe some more complex things, just and tasks and home exercises and things like this that exist that are available?
Well, yeah, thank you. They're great questions. You know, some of them are online, as you mentioned. We have them on the knowledge platform. We can go into some of them. Actually, we shared with you guys. If you just download from that link, you have some. But let me tell you this. Like personally, I would love to share some of those complex ones that we have. But the policy of the company is we share these things with people who buy our devices. So we have certain things, you know, like what you may call it, like more complex ones or advanced ones, or even advanced training ones. They are specifically for people who actually buy the devices. Yeah, but I'm doing my best to make things more available. And as you can see, we recently like published or shared actually one of our algorithms, like in self-paced one, which was like quite thorough. We took us like about 6 months to write it, but I prefer these types. I come from like a research background, and I would love to share things more and more because I believe that if we share more, then that would be people would work on it more, and then we can even develop better things rather than, you know. But you know, I can't change everything quickly. So stay tuned, and if you had anything specific in mind, and if you're using our systems, you know, feel free to contact us. We are happy to help in any capacity. Yeah.
Okay. Thank you very much.
No worries. Enjoy it. Yeah, if there's any other questions, feel free, guys. I think we still have a few people here. I don't know. Yeah, still a few people here. Yeah, I'm here for another minute or so. If you want to chat, yeah, feel free to stay. But if not, we can eventually call it a day. No questions? No more questions? Okay. So thank you very much, everyone. So I enjoyed it discussing all these things with you guys. Great questions, and stay in touch. And hopefully we can have another session to go through. Have a good time, day, whatever time of the day it is now for you guys, and stay safe. Bye, everyone.
Thank you. Bye bye.
Thanks. Bye bye.
Cheers. Bye. Bye, everyone.